All right. Oops. So now we're going to be doing complex rational expressions. So these are basically when we have two of these problems on top of each other, right? We have a fraction, little fractions, two little fractions, and then we have the big fraction, as you can see. So small fractions within an overall fraction. So there are really two techniques to dealing with this. The first technique is best when you only have two LCD factors, and this is identify the small restrictions, or identify the restrictions where any small fraction denominator is equal to 0, multiply the overall fraction by the LCD, simplify, and identify any new restrictions that may appear after simplifying. And then this technique right here is basically doing what we did on the previous part of the lesson to the numerator, doing it to the denominator, and then just doing keep, change, flip. So we'll do an example of each type so you can see what I mean by this. I don't know why this little thing comes up on my screen, but alright, let's look at our first example. So the main thing you're going to notice that's different about these problems is we're actually going to be multiplying the numerators of the fraction by the LCD. Because remember, we have a fraction within a fraction, so we're multiplying this whole top part and this whole bottom part by our restriction. So we have to find our LCD. So basically, what number do all of these numbers divide evenly into? 6, 3, 2, and 4. What number can you think of that they all can divide into? 12. That's part of our LCD. Once you identify the number portion, which one has the largest power on the exponent? X squared. That's your LCD. Okay. Now, once you identify your LCD, you're going to multiply the top by 12x squared and the bottom. And I mean literally the top of the fractions. So that's going to become 12x squared over 6x squared plus 24, because 2 times 12x squared, 24x squared over 3x squared, 3x, all over, and then these both have a numerator of 1, so it's just going to be 12x squared over 2x plus 12x squared over 4x. So all I did was I multiplied basically all the numerators by 12x squared. So the top of the fraction and the bottom of the fraction. Now once you do that, each one of these are actually going to reduce, right? You're going to look at each individual fraction. But I forgot. Before we do anything else, we have to identify our first set of restrictions. So looking at our first set of problems, in each one of these individual 4 fractions, what can't x be? 0. And that's the only restriction because there's no plus or minus in the denominators. So the thing with this topic is you have restrictions, okay, and then you might develop more restrictions as the problem goes on. And we'll see examples like that as we go through. So from here, we're now going to simplify these. So what's 12 divided by 6? 2. And then what's x squared divided by x squared? X. Well, no, it's just 1. X squared divided by x squared is just 1. Plus, and this is going to become 8x. All over. What's this one going to become? Good. Plus 3x. Then we can just simplify that. So we get 2 plus 8x all over 9x. And you can factor the numerator, but if we do, it's not really going to help us cancel anything out. So this is our final answer, or you can write it like this. You can say 2 times 1 plus 4x all over 9x. Either one of these are acceptable. So it's actually really not that bad if you just follow the procedures. So did we develop any new restrictions in the end? Is our restriction still just 0? Just 0. Yep. So you always want to check at the end because sometimes you'll develop a new restriction, which we'll see in some cases. So you have to multiply basically the tops of all of the little fractions by the LCD. And it actually kind of usually cancels out really nicely.
So is that 1 plus 4x fully factored?
Yes, this is the fully factored form.
Would either one of them matter?
No, just keep in mind a lot of your tests are multiple choice, and a lot of tests you'll be taking throughout your life will be multiple choice. So it's just me reminding you that those two are the same thing. And they could be written either way as a multiple choice answer. Are we good to move on to example 8?
Wait, so like, why didn't you use the bottom half of like the big fraction? You like only use the 2 plus 8x, which is from the 12x squared on top and the 24x squared.
What do you mean only used?
Like, you got the 2 plus 8x from the 12x squared and the 24x squared on top, right?
Correct.
And then the 6x plus 3x, that's from like their denominators.
That's from me dividing, yes, these two.
Oh, okay.
Does that make sense? I'm basically just dividing all 4 of these, and that's what I got as a result of those divisions.
I thought you were using the denominator of like the top half.
Oh, no, it just happened to be like
Okay.
the same. Yeah, that's weird. No, I just divided them. You see now?
Mm-hmm.
Okay. Okay. So the next one, first thing we want to do is identify our LCD. So if you ever have just a number like this, this is just 1 over 1 if it helps you visualize things. But we don't really have to worry about it in the LCD because obviously 1 can be multiplied by anything, divided, it doesn't matter. So basically, do you notice any numbers in any of the denominators other than 1? No. So we don't have to worry about a number, but what's the letter to the highest power? Good, x to the second. So that's our LCD. So our denominator, we worry about the variable to the highest power. So now we're going to multiply everything, the tops, both by x squared, meaning the tops of all the fractions. Okay? So that's going to come out to be, you can write it as x squared over 1, or you can just write it as x squared, because 1 times x squared is just x squared. Plus, this will be 2x squared over x. And this one's going to be 9x squared over x squared minus 3x squared over x. So I just multiplied all of the tops by x squared. And
So you find the LCD by what they don't have?
you find the LCD first if they have numbers. You have to find out what's the highest number they all can divide into. But see how we didn't have any numbers to worry about? We just had letters?
Yeah.
So when we just have letters, you just take the highest exponent on that. Whatever one has the highest exponent is your LCD, because they all can go into that amount. Before we move on, though, do we have any original restrictions here on the first set? Just what? X can't be 0. So now we're at this stage. We multiplied everything by x squared. Now we're going to simplify where possible. So this is going to become x squared plus, what's x squared divided by x? 2x. All over. What happens down here? 9x squared divided by x squared is just 9. And then 3x squared divided by x is just minus 3x. Now from here, we're going to need to factor both the numerator and the denominator because they're both factorable. So my numerator factors into x times x plus 2. And my denominator factors into 3 times 3 minus x. And that would be my final answer. But I noticed something else has changed. What do you notice about the restrictions now? There's a new restriction. You see that? So there's a new restriction right here. If I set this denominator equal to 0, 3 equals 0, well that one doesn't matter. And 3 minus x equals 0, if I solve this one, what can't x be also? X also can't be 3. So you always have to check for new restrictions with this procedure, because there's going to be times where new restrictions kind of come about in these problems. That makes sense? Okay. Let's move on to example 9. I'm stuck. Okay. Moving on to example 9. Alright. Well, don't worry about the 1. Do these denominators have a factor in common? Yes, so it's just The LCD is just whatever it is, which is W plus 2. Now we're going to multiply the top and the bottom by W plus 2. So you can put the 1 over 1 if it helps you, yes, that's always fine. So basically we're going to multiply the numerator of each of these fractions by W plus 2, okay? So when you multiply the numerator, you end up with something like this. Just multiplied all the numerators, and of course the 1, you got to multiply that by W plus 2 as well. Now we're going to see if anything cancels out, but before we do that, because I always forget, what's our restriction originally here? W. Everybody see why it can't be -2 in the beginning? Okay. So we're going to cancel these out.
Well, okay, so where where is the beginning? Why can it equal -2? I mean, I know why, but like, where did you find?
Set the original denominator equal to 0.
Okay.
Does that make sense? So we multiplied all of the numerators by W plus 2. We end up with W over, because these canceled out, W plus 2 minus W. See how much that simplified down when we multiplied everything by the LCD? So what happens in this denominator here? What happens to the W's? They cancel out, which just leaves me with W over 2. And that's the final answer. And are there any new restrictions? No, because there's not even a variable in this denominator. So
That's why you don't multiply the 2, like you don't distribute the W to the W2s because you want to see if you can cancel out.
exactly, yes. You don't want to distribute unless you're trying to combine new terms together. Because otherwise you're just going to be working backwards doing it. You're going to have to factor it and unfactor it and everything. It's just going to be a bunch of steps. So how does everybody feel about 9?
Was that technique 1 still that we're using? Like
Yes. We haven't used technique 2 yet. We actually will on example 10. There's no new restrictions because see how there's not even a variable in the denominator anymore? The only time you're ever going to have a restriction is if there is a variable in the denominator. So this one's good to go so far. Alright, so let's go ahead and try example 10. So the first thing you want to do when you see a question like this is rewrite it, but factor those denominators, okay? Because unfactored denominators are pretty useless to us here in this kind of question. So for the first denominator, what are factors of 8 that add up to positive 6? Good. So this breaks up into 4 and 2. And then for my denominator, what are factors of negative 20 that add up to negative 1? Good. Negative 5 and positive 4. So at this stage, we have to identify some restrictions on the domain. So what do you think some of our restrictions on the domain are here? Good. Negative 2, positive 5, and negative 4. I just set all of those pieces equal to 0. So now I'm looking at each fraction separately, the top and the bottom. Do these fractions have any of the factors in common? What do they have in common? Good. What does the top one have that the bottom one doesn't? Good. And what does the bottom one have that the top one doesn't? Good. X minus 5. So see how if you look back at the rules, if you have 3 LCD factors, they recommend you use the second method. Okay? So you can use the first method if you want. It's just going to be more math. So when you have more than I'd say more than 2, I believe, is the main rule here. Like the main idea is you want to use the first method. So, or the second method. So, in this case, we have 3 factors, so that's going to be a lot of math. So what we're going to do here is keep, change, flip, okay, for the fraction. So we keep our first fraction. Yeah, exactly. We're going to do that. Exactly. We're going to keep our first fraction, and then we're going to change it to multiplication and flip our second fraction. Now, once you get to that stage, you're going to cancel anything out that can be canceled. So right away, can we cancel anything out before we even multiply here? The x plus 2. Now we're going to multiply across. That's going to give us x minus 5 times x plus 4 all over 1 times x plus 4, which is just x plus 4. And then in the end here, what can we cancel out? The x plus 4, which leaves us with x minus 5 as our final answer. So all of that was really just x minus 5. Make sense? So when you get a lot of factors like this, just use the keep, change, flip method. It's just easier. And just so you know, you can use either method on either problem. It's not going to be wrong. This is just going to be the path of least resistance if you do it the way that it's recommended. So the first thing I want to do is identify my LCD. So do any of these have any factors in common here? They all, well, at least 2 of them have a what?
X plus 1.
Good. They all have an, well, not all, but 2 of them have an x plus 1. And then, what does one of them have that none of the other ones have? Good, an x and then also an x minus 1. So that would be our LCD. So, in this particular case, we have 3 factors. So, you can do keep, change, flip here. Or, this is one of those situations where it's really going to be either method you choose is going to work out okay. Because it's kind of like we have just a few too many factors, but it's probably going to be easier than using the keep, change, flip method. Because if you do keep, change, flip, you still have to find a common denominator for these. So let's do the first method here. But if you did the second method, it's still going to work out too. So, I'm going to do the first method, which is to multiply all my numerators by the LCD. Sorry, I'm just concentrating to make sure I don't make a mistake here because it's easy to mess something up at this stage. So I just multiplied all my numerators by the LCD. Every single numerator was multiplied by the LCD. All 4. Once you do that, you're going to see what you can cancel out in each one of these fractions. And there's going to be at least one thing. So the x's here will cancel out. The x plus 1s will cancel out. The x minus 1s here. And the x plus 1s here. I'm going to rewrite it as is. So this is going to leave me with x plus 1 times x minus 1 times x minus 2 plus 2x times x minus 1 all over 3x times x plus 1 minus x times x minus 1. That's what you get when you simplify all of this, basically. And we forgot to do our restrictions earlier, so looking at the original fractions, what would be the restriction on this first fraction here? X cannot be. The second one, x cannot be. Yeah, it can't be positive or negative 1, right? So from here, the problem is we probably should have done the other method because we're not wrong. It's just we have to multiply all 3 of these binomials together and then distribute this. And yeah, it's going to get pretty long. So in this case, I'm not going to ask you to do on this complicated and simplify it. This is a lot too much work. You got to multiply three binomials together. I wouldn't have you do this. So at this stage, I'm just going to tell you that all of this simplifies down to x minus 1 over 2. And if you want to go back and try to figure it out, that's fine. I won't ask you to do one this long on your own. And example 12 is more of an honors question. So we don't have to do that one. We'll skip it. If you guys want to see it, let me know. I can do it for you. But it's pretty long. So that's it.